Yeah, good morning to everyone. Good morning. And thanks to Professor Dhami, Professor Benwet, and Professor Paola for giving me the opportunity to interact with you, young and dynamic engineers. Okay, before understanding the engine, we just try to understand what is an engine, because today we will talk about the engine management system. Okay. Now, can you just tell me what you understand about the engine? What is an engine? You will bring here.
Yes. So otherwise a battery lecture will be.
So I will change whenever required. Right. Engine is a energy conversion machine, right? Which convert the chemical energy, which is in the fuel, into heat energy. Then subsequently, heat energy is converted to mechanical energy, right? Now, similarly, to convert this, what you need any fuel. We call it hydrocarbons, right? Like petrol, diesel, LPG, any composition which consists of hydrocarbons. And what else you need? You need fuel, and then you need oxygen or air, right? Air we are taking, and oxygen is used to oxidize and the combustion take place. CH4 means plus oxygen, CO2 plus H2O is the outcome, and you get the heat energy also, depending upon the calorific value of the fuel. A internal combustion engine inhale the air and fuel is injected or mixed in the air. Now, to make it more clear, let me understand, we have a beautiful engine. Everybody has a beautiful engines. This is your body. What you do? You are just taking carbohydrates. Any kind of fuel you take, it is a carbohydrate, right? And the carbohydrate consists of carbon and hydrogen. And you inhale, what you inhale? Air. And that air, when it get inside, it break up that carbohydrate into CO2 and H2O. So when you are exhaling, some part of oxygen is converted into carbon dioxide and there is a water vapors. Now, how much fuel you need whenever you want to increase the power of the engine? Like suppose you want to have more energy. It is not like that you eat more and you will get energy. Even your stomach may be in problem, right? Similarly, it is not necessary that you give more and more fuel to the engine. It will give you the more power. It is not true. Whenever you want to increase the power of the engine, at that time, we have to increase the air also. So air and fuel, the quantity of air and what time I should inject the fuel, what is the quantity of the fuel which I have to inject, that is very critical. Engine management system is about to control all these parameters, right? So that if you remember, like earlier, we have a carburetor. You know that carburetor was used to mix the air and fuel. Now, if we come to the engine, because my more talk will be revolving around the spark ignition engines, because there are two categories of engine. One is the petrol engine, one is the diesel engine. Petrol engine is a spark ignition engine, diesel engine is a compression ignition. And sometimes to make it more clear, so that you remember that, you can also categorize like spark ignition engine. It's sort of a arranged marriage. There are two types of marriage, arranged marriage and love marriage. So that you can recall, because it is easy when you interrupt with the story.
So arranged marriage is like, because marriage between air and fuel. So when we have to mix them properly. So in spark ignition engines, I am mixing the air and fuel before entering into the combustion chamber. Are you understanding?
Yes.
Like in the intake manifold, air is coming. In the intake only, I am injecting the fuel, so that your mixing take place before it mixture goes to the combustion chamber. And in the combustion chamber, at appropriate time, we are giving the spark so that ignition is combustion take. So it means there is a time before happening to the combustion, there is a time so that air and fuel can mix with each other, they can understand each other, and they can make a optimum ratio and good mixing conditions, right? Because mixture preparation also take time. Suppose you are adding sugar in the milk or tea, then you have to stir it. Why you are stirring? So that mixing is proper. So similarly, air and fuel, I have to mix it properly by creating some turbulence or by creating some phenomena, so that air and fuel are mixed, having a homogeneous mixture. So this is the arranged, means before initiating the combustion, both are allowed to meet and mix. This is a love marriage. You understand each other. In arranged marriage, diesel engine is an arranged marriage. Like air is already in the combustion chamber and you are injecting the diesel fuel directly into the combustion chamber. You don't allow, there is a very little time for the mixing. So immediately it is a heterogeneous. So I think with this example, maybe it may be easier to understand. That is the basic fundamental difference between the petrol engine and diesel engine. Now, the important thing is that we understand what are the fundamental requirement of the engines. Like we have mentioned, we need a, so my talk will revolve around the petrol engine, and petrol engines are used in motorcycle, in three-wheeler, in all type of cars. Mostly they are spark ignition engines. Heavy duty application, trucks, buses, generally they have the diesel engine, but nowadays you can find cars also in the diesel engines, right? So we talk about the engine management system related to the spark ignition engines. Let me understand the basic properties, basic requirements of different aspects of the engines. Now, as it has been indicating that, and we have discussed that air is one of the very important requirement. Whenever you want to develop more power, it is not the fuel, it is the air which you have to increase. And you can understand even engine specifications are specified in cc. This is 100 cc engine. It is 200 cc engine. It is 1000 cc engine. It is 2000 cc engine. That cc, do you know what it means? That cc, cubic centimeter, and what physical meaning it has? Volume of cylinder. So, and volume of cylinder is filled with yeah, so basically it defines the how much air you can suck in, because fuel quantity is negligible as compared to the air, right? So it is the amount of air the engine can suck. More air it can suck, more it can produce the power. Is it clear? So we have the air, then depending upon the type of fuel, we need a certain amount of air and fuel ratio. Suppose it is a petrol fuel. What is the air fuel ratio we need for combustion? How much? 17:1. Anybody else? 16:1. Anyone else? So we get two figure now. One is 16:1 and 17:1. Anything else? More precisely, it is around 14.7:1. We call it stoichiometric air fuel ratio. Stoichiometric, do you know what is stoichiometric air fuel ratio? It is not standard. it is the chemically correct air fuel ratio. The, like suppose approximately composition of the petrol. Do you know what is the, how much carbon, how much, what is the formula of the petrol? Because my all design start from here. It is approximately C8H18, approximately, not very accurately, but it is sufficient to calculate. If you, what you can do, I can give you exercise also, because if anybody is keen and understand the fundamentals, you just write down the C8H18 and react it with the oxygen and make it a equation, balanced equation. And from here, you can find out what is the amount of air you need to burn 1 mole of fuel, how much mole of air is required, or 1 kg air, to burn 1 kg of fuel, how much air is required. This is the backbone of the engines. If you don't know this, like it is a foundation, so you can't erect the building. So C8H18 plus oxygen, then again in oxygen, when you are burning the oxygen, I am finding out the air fuel ratio, not oxygen. So, and what is the percentage of oxygen in the air? 20. Anybody else? 21. Anybody else? 26. So it means, more precisely, it is around 20.9%, approximately 21. You can say it is the right answer. So 21% oxygen is there. So what you have to do when you are calculating the, from that equation, so you have to multiply with the this factor to calculate the, find out the air. On internet also it is easy. So my request is, please try to do this exercise. Okay. Now I have, suppose 1 gram of fuel I have injected. So how much air I need? 14.7. This is chemically correct, what is known as, based on the equation which I have given you, calculated. So we call it stoichiometric air fuel ratio. Actually in the engine it may be slightly more or it may be slightly less. I can provide slightly more, I can provide slightly less, or I can provide stoichiometric also. That depends upon the engine requirement. But the variation is little bit, not 50% or like that. It may be plus minus 10% you can provide, depending upon the, whether you need more power, whether you need more efficiency, whether you need lower emissions. It depends upon the, what you are looking for. Appropriate air fuel ratio, we have discussed this. Now it is clear to you what is the air fuel ratio, what is the stoichiometric air fuel ratio. For petrol it is 14.7, and to calculate this you can use the equation C8H18 plus oxygen, and oxygen के bracket में आप डाल सकते हो उसका correction factor to calculate the amount of air. Now air and fuel you have mixed and it is now entering into the combustion chamber, right? What you need now? Very good. Now you need spark. And spark intensity is important. Now there are two things now. One is the, what should be the intensity of the spark? If spark is very weak, it may not be able to ignite the mixture. If the spark is too strong, it may burn the spark plug, life may be less, or it consume unnecessarily energy. So another important point is, one is the appropriate intensity of the spark, and what is that? What else? Suppose I have given a spark of enough energy. What is another parameter which is important? Timing. What time I should create a spark? If I am creating before the TDC, 50 degree before TDC, it may not ignite. 100 degree before TDC, it may not ignite. So I have to ignite it very close to TDC, maybe 10 degree or 12 degree before TDC. So it means mixture preparation, we have discussed proper intensity of spark at appropriate time. So now I summarize. So air and fuel is important. Air fuel ratio is important. Then appropriate intensity of the spark at appropriate time. If I want to manage all these things, for that I need engine management system. Now, when you will calculate that, you can just see the composition by volume of the air is 20.95 oxygen, but you treat as a 21% also, absolutely no problem. And nitrogen is around 78%, the rest are some inert gases, so that can be ignored, right? Okay, one terminology I want to discuss with you, that is, like we talk about 100 cc and all that. You might have also heard about the volumetric efficiency of the engine, right? Can someone define what is the volumetric efficiency? What is the volumetric efficiency?
Displays volume upon volume of air.
Like displaced volume is, like suppose we are, let me give you an engine. Suppose you consider a Alto engine, which is 800 cc engine, right? Or any engine which you know, maybe if you have bike 100 cc, 150 cc engine. Suppose it is 150 cc bike. So 150 cc is the displacement volume. So what it means, what do you mean by volumetric efficiency then? 150 cc, when it will, piston will move, it will displace 150 cc. Whatever diameter is the pi d square by 4 into stroke length, right? Then what is the volumetric efficiency? Because piston will displace that much only.
Total volume on clearance.
No, that is the compression ratio, like something, it is not even a compression ratio, but that is not the volumetric efficiency. Displacement will remain same, no? Or it will change. The piston is moving from the top to bottom. So displaced air will remain same. So what is volumetric efficiency? Because it is very important. When I go in the engine management system, this is very important parameter. So this is like when my piston is moving from top dead center to bottom dead center, it is sucking some amount of air. The volume remain same, mind it. The volume of the air will remain same, but if you have a throttle or something in the intake, like you use in the carburetor and all that, so the density of the air will reduce. So mass of the air which is sucked in, that will reduce. So it is the mass of air which the engine can actually suck in due to the displaced volume. Okay. Actual mass of the air which is sucking and the engine which it can suck theoretically. It is the mass of the air. You get me now? So whenever you are using any throttling, it is reducing the density of the air. So less air will come. Volume will come same, but it is the mass. So when we are talking about the volumetric efficiency, most of the time, all the engineers and even students, they confuse with the volume of the air. They think it is the volume of the air, actual volume to the displaced volume. So it is, first thing is, it is not the volume. What is this? Mass. Is it clear to you?
So I have throttling which is mass.
When you are having the throttle, what it is doing? It is providing the restriction to the air. If suppose this is the passage, I have blocked it completely, or only I have opened only 5%. It will allow very less air to go. Why? Because it is stopping there, and only when through that hole it will go, it will, by reducing the density of the air. Are you getting me? Like when I am blocking it, I can block it 100% also. Maybe 1% leakage, so very little air will go. When I am making the full throttle, when you are accelerating the car, what you are doing? You are opening the throttle full. So volume is same in the displaced volume, but it is the quantity, it is the mass of the air which is increased. And 99.9% students and engineers, they make mistake here. So even if you have learned today this, your day is successful. Okay, next. Another important thing is density of the air. You know, it is dependent on the temperature and atmosphere pressure also, right?
Yeah.
If in summer I may take my vehicle to Rajasthan, the temperature may be 45 degrees Celsius. Your engine is same 150cc engine. At 47, and another bike I have taken to Simla, their temperature may be 10 degrees Celsius. Okay. If the temperature is lowering, we can say in the winter. In the winter, temperature may be 5, 6, 7 degrees. Even in Chandigarh, maybe suppose 10 degrees Celsius. And one is you are in the peak summer noon time. Your same engine is operating. So in winter, definitely the engine will take more. In winter, engine will take more air in winter or in summer? In winter. Because the mass of the air will be more. Why mass of the air will be more? Volume is the same, 150cc. Mass is into density. Density will, bolo yaar, density will be more. चलो मेरे को ये बताओ. Suppose today what is the temperature? 16 degree. What will be the approximately density of the air? 1.2. So if the temperature is low, 0 degrees Celsius, then density will be increased. So mass of air will increase. So in winter, the engine can develop more power. So, and your air fuel ratio will also change. And you have to, or if you want to maintain the air fuel ratio, you have to change the quantity of the fuel. And depend all this effect of the weather, temperature. Then you talk about you may go to Mussoorie also, maybe at the hills. Your vehicle may go to Kashmir also. So at the high altitude, the pressure is decreasing. If pressure will decrease, what it means? Density will decrease. Density of the air will decrease, means mass of the air which is sucking by the engine is decreasing. So you have to adjust that for the air fuel ratio. Now, till now, whatever we have discussed, is it clear to you? Right. So if all these now earlier I was using a carburetor. So carburetor cannot compensate for all these variations. You understand? If temperature is high, carburetor jet, because jet is fixed, it will give the same quantity of the fuel. Another important thing I am going to tell you. This is the fuel. That important thing is, suppose today you have purchased a bike. After 5,000 kilometers, your bike is running on the roads. It may be running on the dirty roads also. And in the air, dust is there. So you know we are using a air filter.
Excuse me, sir.
Yes, please.
Sir, can you please explain volumetric efficiency?
Volumetric efficiency is the mass of the air
which engine is taking actually divided by mass of the air which engine can take theoretically. So it is the mass of the actual air divided by mass of the theoretical air which the engine is taking. Okay. Now, if my air filter is blocked with the dust, what will happen? It will restrict the air to going to the engine. When the engine was new, a filter was new, suppose I am taking an example. Engine was taking around 50 milligram of air per stroke. I am giving you actual figure. Okay, 50 milligram of air is sucked in by the engine when the filter is brand new. After 5,000 kilometers, due to the dust, some restriction is created. The amount of air the engine will take now will be less or more? Less. So instead of 50 gram, it may be 48 milligram. Instead of 50 milligram, it may be 48 milligram. So it is reduced by 2 milligram. If the amount of air is reduced, but if there is a carburetor, the fuel will be same. What will happen? Mixture will become rich. Mixture will become rich means your fuel economy will be decrease. Is it clear? So like that, there are many parameters. After some time, you have covered a bike of 60,000 kilometers. Your suction power, your vacuum, due to the wear and tear, will reduce. Amount of air taken in by the engine will reduce because it is the piston effect. Piston and piston is water, it will not suck. The vacuum created by the engine will reduce, or you can say compression ratio will slightly reduce. So air quantity. So all these variables cannot be taken care by the carburetor. So that's why.
What in case of air filters containing oil in it?
Even if air filter is having the oil dipped, there is a mesh of iron fibers. So there even you find lot of dust is there. So pressure drop will increase whatever the air filter may be, whether it is the paper type or it is the oil filter, after some time. The variation in pressure drop may be different depending upon the design of the engine, because there is a very important parameters in the air cleaner design, that is the dust holding capacity. Suppose whatever if you design this bottle, so this can hold certain amount of water. Are you getting me?
Yes.
Now I have two bottles. So these two bottles, they have a different capacity, right? This can hold maybe 200, this may hold 400. Similarly, I am designing a air cleaner when I am using in the vehicle. What should be the dust holding capacity? You can note down this terminology. Like this bottle can hold 200 ml of water. Similarly, all air cleaner are designed, their abbreviation is dust holding capacity. Whether they can hold 10 gram of dust, 20 gram of dust, 40 gram of dust, that is you can decide at the design stage. For example, for a motorcycle, and how I decide that, I keep on increasing the dust. After some time, the pressure drop will increase. So there is a limit. Suppose earlier the pressure drop is only 2 kilopascal. So some certain amount of air was going 50 milligram. When the dust is 10 milligram, the pressure drop across the air filter is increased from 2 kilopascal to 4 kilopascal. And if I increase the pressure further, 4 kilopascal to 5 kilopascal, my engine will not perform well. So I limit that. So in my design, I say, okay, the amount of dust the air cleaner or air filter can accumulate before reaching the terminating pressure drop
and that terminating pressure drop is what you decide. The delta P should not be more than 2 or 3 depending upon the designer. Is it clear? So any filter, when it's even this is the same thing with the fuel filter also. When you are passing the fuel filter also, after some time, 10,000 kilometer, 20,000 kilometer, you are changing it. Why you are changing? Because the dust is accumulated, and when the lot of dust is accumulated, it causes the pressure drop. And we decide what is the terminating pressure drop. Means the pressure will increase gradually, but there is a certain value after which the engine will start deteriorating significantly, and there I say, okay, now change the filter. Clear? So there is an abbreviation: dust holding capacity of the air cleaner, air cleaner efficiency, generally that is around 99-98%, and initial pressure drop and terminating pressure drop. These are the two important parameters for the air cleaner, which decide the dust holding capacity and life of the air cleaner.
So how actually this pressure drop is, what is this pressure drop exactly?
What is the question?
So where is this pressure drop occurring? On filter side or piston side?
The filter side, across the filter. Suppose I have pipe something and you block that pipe and you try to suck. Can you suck then? If I use a very thin paper on the tube, you may, or a simple cloth of cotton, you may be able to suck through the pores. But if I increase that thickness or I put some dirt, it is difficult to suck. So the pressure drop is increasing across the media, across the air filter, across that element. Is it clear? Air filters we have discussed already.
What if we add extra snorkel to the cars? So what can the air fuel ratio, can it be improved the efficiency, or the power should be increased with it?
No, that snorkel or cyclone we are adding in off-road vehicles or in the trucks where the dust is more. So if you use only air cleaner, they will choke very quickly. Suppose in a tractor or in truck, you are going in the dirty area or in the mines area or even some off-road vehicle or even trucks and buses where you need more dust is coming. So we use one is the cyclone. What cyclone do? Due to they create a swivel motion, and in that motion air particle can move in and they change the direction suddenly. So air can move and change the direction, but dust cannot do that. So dust is accumulated there only. So dust is separated out by the swirling motion of the air without the media, without the air filter. Suppose your dust in the air is, so the heavy particle maybe of 200 micron, the bigger particle, they will separate it there only. And very, very fine particle which air can carry, they are going to the air cleaner, and those particles are, even we are having that what are the technique to use or to separate the dust. But that is important, what is the dust size. Suppose in the home you are using atta छानने के लिए जो छलनी होती है, so that depend on the pore size. If that is very thick, the lot of that dust may go. If it is fine, though it is a segregation. So in air cleaner, the size of the particle is very big. Whether you are doing 20 micron, 40 micron or 80 micron. So the snorkel system or this cyclone system are to separate the heavy particles of the dust from the air. So it is done in two zones. One is there, and then actual filter will come, so that your actual filter life will be more. Are you getting me? And that you can remove and you can clean it. Like our Omni vehicle, this and all this a little bit commercial vehicle, they have this snorkel and cyclone system. Car generally don't have, because car generally it is supposed they are running in the cities only and on the roads, so they are more, they don't need. So experiments show that your dust holding capacity, I can give you a typical example of Alto 800cc. The dust holding capacity is around 100 gram of dust, and you can change this air cleaner, you can clean it after 10,000 kilometer, but we advise at every 5,000 kilometer, because it depends upon the environmental condition also. Suppose somebody is running the car in Rajasthan where dust is more, somebody is running in Chandigarh, the dust may be comparatively less. So it depends upon the environment, but generally it should be cleaned after 5,000 kilometer. Even very advanced car, आपके यहाँ पे board है क्या? Very advanced car, what they do, across the air cleaner element, I am putting the pressure sensor. I am measuring the delta P there. In the new car, suppose the delta P may be say 95 kilopascal, or delta P is 5 kilopascal, between the atmosphere and that 5 kilopascal. When the delta P is increased, then I glow a light, because I have put a pressure sensor, and that will indicate now clean the air cleaner, because otherwise it is difficult to you whether it is, what is the pressure drop across that. So but that require additional cost. You can, so you can put the pressure differential sensors, and you can put that light in the vehicle, so it will glow when the pressure drop is increased to the terminating pressure drop. But all these things you can do when you have the fundamentals. Even suppose before coming, I can assure you, like if you will listen the talk carefully, your neuron structure, your brain structure will change after every hour. When I will leave the class, your neuron structure, your brain will be in a different synaptic weight. That I can assure you. And you can be more creative, because when my fundamentals are clear, my interest is created. And here in 1 day or 3 hours talk, we cannot teach you each and everything, but we can create the fire in you to learn the things. And the fire is created when I am able to create the interest. And interest is created when you are able to understand. Because we are escaping from the things to learn when we don't understand it very fundamentally. So interesting. Like you see, this is a bit like you can think, okay, can I make a logic in the filter, and it is good. Like I can put in my vehicle, okay, when it give the light, I should change the air filter, and then we say, okay, now you don't change the air filter when the light comes. You clean the air filter and reuse it. Then you can do it 3 times. After that, its dust holding capacity will be totally the paper. So that's why it is advised in first service, you can clean the air filter, in second also, in third also. But at the 4th time, you replace that. Now you understand how important is air cleaner. I tell you, if you want to improve the fuel economy of your car, of your friend's car, you can advise him. These are the practical. They say, yeah, he's a good engineer, he knows the facts. So we should be a practical engineer, not the theoretical engineer only. We should be capable to correlate the theoretical aspect and the practical aspect. We should consider the implementation point of view of that. And even now you can think, what type of paper I should use for the air cleaner? Are you getting me? There are different type of paper, non-woven type, and what should be the pore size of that paper. Even that is very important. जैसे मैंने बताया ना छलनी के लिए पेपर भी there is a pores, and if the pore size is supposed 20 micron, it means the dust of size of less than 20 micron will carry with the air. No. So that is also very important aspect. Even each and every component of the engine management system and engine is involving in a big technology. Even what you see, very simple air cleaner. Many research are going, many patents are going. Number one, there is expertise available only who do the paper development. What type of paper I should use. Now they are working on the nanofiber, so that by I told you the pore size, because if I have the nanofiber, I can increase the dust holding capacity without increasing the pressure drop. That is what nanotechnology means in that. So paper media is one. Then what is the shape of the air cleaner? There are many shapes: split type, round type, square type, rectangle type. That again are number of pleats. Now there is area, because I have to increase the surface area. How I can increase the surface area of the air cleaner so that it can accumulate more dust with lesser pressure drop. Okay, here you can just see maybe this is the air is coming from here, right? So this is the sort of a, you can assume sort of a air filter type like here. That air should be clean and it is going. Anyway, this is giving the stoichiometric air fuel ratio for different fuel. Gasoline, CN, H1.8N. If you are assuming 8, then you can just do diesel is like this, propane, methane is CH4, methane is CNG. In after lunch class lecture, we will cover alternate fuels. In that we will cover CNG and LP other, methane and propane also. Hydrogen H2. Now this is the only fuel which don't have the carbon. So recently we have done a project which is for a hydrogen engine. So there are 2 engines which we have converted into hydrogen. So they are running now. And the beauty is, because there is no C, there is no CO2. There is no unburnt hydrocarbon. There is no CO emissions. So CO is not there, HC is not there, and CO2 is not there. So it is almost emissions free. Can we say? More or less, but there is a problem. Because nitrogen is in the air, it reacts with the oxygen and we produce the nitric oxide. In other engines also we are producing nitric oxide. So nitric oxide is produced. So that we have to find the technique how to reduce the nitric oxide or NOx. Because there are 3 pollutants which we have to control: CO, HC and NOx. Are you feeling your neurons are activating? So just involve in this. Next is, you see, now the question arises, why I should change the air fuel ratio? Now let me understand the automotive engine and even design set engine. That first we talk about the automotive engines. When you are driving a car or bike, you see, first you start it. It is running in idling. Then you put first gear, accelerating. Then second gear. Then de-accelerating. Somebody comes again applying brake. So automotive engine is operating under varying load and speed conditions. Right? If there is one speed engine, you can optimize the air fuel ratio and it will run at that RPM only. Then set engine is relatively easier to tune it, calibrate it. But automobile engine is acceleration, de-acceleration. Sometimes you are sitting alone, sometimes your family is sitting, load changes, speed changes. You are running at 60 kilometers, you may run at 100 kilometers, you may run at 80 kilometers, you may run at 30 kilometers. You are going to Simla, again load changes. So it is a very dynamic conditions. And what is the effect of all these things? Let me have a look on that. See, if I need, this is the power. Now, if I need more power, for that I have to make the air fuel ratio slightly rich. I have to give slightly more fuel as compared to the air. I will get the more power. But it doesn't mean if I make more fuel, more and more, power will increase. It is up to a certain level, and that level is approximately 12.5 ke aspas. At a 12.5 air fuel ratio, I will get a maximum power. But At what cost? My fuel economy will increase. This lower curve is fuel consumption curve. Now suppose you say, sir, I am bothered about fuel consumption. My bike should give maximum average. It should run in 1 liter of petrol 100 kilometers.
Hello. Hello.
You have to tune your car or bike where you get maximum or lower fuel consumption. Here. So what we can do, so this is what you are getting the minimum fuel consumption. So minimum fuel consumption point is at 16 and power point is at 12.5. Yes, please.
Hello.
Yeah, yes, please.
Yes, sir, there is one small question from my side. How is the humidity affects in the suction process of the air?
Clearly.
Hello?
Mic code.
Hello.
Yes, please.
Hello.
आप बोलो.
बोलिए.
Hello. Sir, can you hear me? Hello.
आपने ऐसे what we can do, you can ask everybody, maybe we can keep 10 minutes for question answer and at that time they can ask. वो डिस्टर्बेंस आ रही है ना उससे. So it means, you know, it is very interesting to understand. So if I need more power, I need air fuel ratio of around 12.5 or 12.4 approximately. So you don't catch me, okay sir, आपने 12.5 बताया था. So it is approximately, means we can say definitely we need slightly richer mixture, more fuel. The point may be different. It depends upon the engine also. It depends upon the fuel quality also. But for if I want better fuel economy, air fuel ratio is, I need around 16. Now, it means different mixture strength are required under different operating conditions. So when I am calibrating the car, I know when I need power. Suppose I am accelerating, I need power. When I am going at a steady speed, so I can use the linear mixture also. So this is what is a calibration means. You have to do it. But here the idea of this is that different type of air and fuel ratio are required under different operating conditions. Do you agree with me?
Yes, sir.
Okay, so you please remember this. Now, one slide we have discussed with the power and fuel consumption. Okay, so when you want more power, you have to sacrifice the fuel economy. When you have get the more fuel economy, you have sacrificed the power. Okay, now what? Let's see next. If you see this is the flame speed. You see the flame speed is maximum at a stoichiometric, little than richer than the stoichiometric. So here the flame speed is around maximum around 14:1. It means your combustion will be much better when you operate in this range. Okay. Now in next slide we go to the effect of the air fuel ratio on the. This I am combining all flame temperature, power output and fuel consumption. Right? Now let me see on the emissions. It is again a very interesting. Now I have to control all the emissions. You want to control CO. You tell me what are the pollutants you are controlling in the engine? Carbon monoxide, nitric oxide, hydrocarbon. Very good. So we are controlling 3 emissions. Now fourth emissions regulation is also coming. CO2 also we have to control in future. But at this moment, we are controlling all these three. Now look at this, how the air fuel ratio is affecting the all these three emissions. Now first you see this bell type of curve. This is, it means this is the NOx. NOx is maximum when your air fuel ratio is very close to stoichiometric. And why NOx is maximum? Because NOx is the phenomena which is directly proportional to the temperature of the combustion chamber. If the temperature will be more, NOx will be more. NOx formation take place at around 1200 degrees Celsius. When the temperature inside the combustion chamber is around 1200 degrees Celsius, at that time nitrogen can react with the oxygen, otherwise it will not react. So it should be 1200 or above the 1200. Okay.
Sir, if the air will be less at the combustion time, what will the effect on carbon monoxide?
What is the question?
If the air is less at the time of combustion.
Air is less.
At the time of combustion.
हाँ, तो CO will increase. वो डिस्कस कर रहे हैं अभी हम. अभी मैंने पहले नॉक्स का बताया आपको. नॉक्स से कोई रिलेटेड क्वेश्चन है तो आप पूछ सकते हैं. वो CO का तो मैं क्वेश्चन बताऊं. अब ये देखिए आपका CO का कर्व है. ये CO में क्या है? यदि यहां पे मैं सपोज here the if I am making the mixture rich, more fuel, CO will increase. So this is the point as stoichiometric. If I am increasing the fuel, yani ke if I am increasing the air fuel ratio, CO is increasing. In other words, you can also say if I am reducing the fuel quantity, I am making the mixture leaner and leaner. You see, the CO will decreasing. So if I am getting the better fuel economy, I have to make the mixture lean. Means CO will also decrease. Now come to the hydrocarbons. Hydrocarbon is also increasing when the mixture is rich. It will come down and it is minimum around stoichiometric.
Sir, carbon monoxide emission that will depend on temperature now.
No. They are function of air fuel ratio. When hydrocarbon is HC emissions are reduced when I am making the mixture very close to stoichiometric. And if I am making it leaner, again it will increase. It means if I want to reduce the CO, my requirement is different. If I want to reduce the HC, my requirement is different. If I want to reduce the NOx, आप समझ रहे हो ना, the complications. If NOx I want to try to reduce, my CO and HC will increase. So to balance all these things is a very difficult task. It means what I have to do, I have to optimize the power, I have to optimize the fuel consumption, I have to optimize the CO emissions, I have to optimize the hydrocarbon emissions, and I have to optimize the NOx also. And at the same time, I have to optimize the drivability also. So, and each and other parameter, they are contradicting each other. You see, I can reduce the CO, but HC say I will increase. I can reduce the NOx. So, but at certain cost. So you have to balance out all these things. And this is the art of calibration. Right? I think we have a break now. Abhi, if there is any questions, then we can, somebody was asking if you can just check if some. हाँ उनका एक बार पूछ लो आप क्या क्वेरी है.
अरे स्पीकर नहीं चल रहा है. लैपटॉप के पास से बोल दे सुनाई देगा. हेलो. हेलो. कैमरे के पास आके. हेलो.
Hello. Yes, please. Yes, please. Any question, please?
Hello.
Yes.
Hello.
Yes, please.
Sir, how humidity affects in the air cleaning?
Relative humidity, like if it is more, then air cleaner life will reduce. Any other question? Okay, we can proceed because there are so now let me summarize. Optimum air fuel ratio is different for peak power. Optimum air fuel ratio is different for good fuel economy. Optimum air fuel ratio is different for minimum CO. Optimum air fuel ratio is different for hydrocarbon emissions. Optimum air fuel ratio is different for minimum NOx. So all are conflicting each other. To manage all these things, the carburetor, which was till now we are using, is not capable to meet all these requirements. So hence we have changed the technology from carburetor to electronic fuel injection system, which is our what we are talking about. So this is sort of a history now. This is the history already in cars. No car is fitted now with the carburetor, but most of your motorcycle and three-wheeler, they are fitted with the carburetor. But to update you, do you know by 2020 all the motorcycle has to change to EFI? In the BS6, which is we are going to implement in 2020, there will be no bike which is running on the carburetor technology. And even now, there are certain bikes, they have started using the electronic fuel injection system, or you can call it engine management system. But Euro 6 cannot be met by using the carburetor technology. So the topic which we have taken today, it is the emerging technology, futuristic technology for all the two-wheelers and three-wheeler, which is already implemented in the passenger cars. So it is highly mandatory because all your mechanical, all your technician, all your engineers, your bike will go on the servicing also. They have to change their attitude, and it is the right time to start with that. So my request is even suppose your students whenever wherever to EFI, most of the mechanic, they can repair the bike. That will not be in future. Like car, mechanical like wheels, brake, they may do, but engine related parameters they cannot touch even. So it is a big change. So my sincere that we can, because when I'm looking at the courses sometimes, last time I got some courses from some universities, I was surprised that syllabus which is covered in the syllabus of your engine courses or mechanical engineer, the technologies are totally obsoleted. They are meaningless for the industry. If today, suppose somebody want to join the Honda motorcycle, so they need an engineer who can work on the EFI system. They need an engineer who know the emerging aspect of engine technology. So my request is at the same time to all the teachers, because this is the right forum, that number one, you can request to revise your syllabus also. I'm not saying like suppose the carburetor is covering, say, to reduce it maybe from existing 20% to 2% and replace that with the latest technology. All the even the experimental work of the CFI system. So that is the purpose of this. So now by this time we understand the fundamentals, fundamental requirement of the engine, about volumetric efficiency, about the intake system, about the importance of the air fuel ratio, and because we know the carburetor was not capable to meet all the varying requirement of air and fuel under the different operating conditions of load and speeds. Hence, we have to change, we have to replace the carburetor to the electronic fuel injection system. Okay, please. The ECU. What are the actuators? Where we have to mount, and what are the principles and design aspect of each and every sensor, and why we need those sensors. Another aspect, the EFI for car is totally different. For motorcycle, it will be slightly different because the motorcycle cost is say around 50,000 rupees. The car average cost may be 6 lakhs rupees. So if I am developing a EFI system for a car, and if the cost is 30,000 rupees, car can absorb that cost. But in a bike, which costs 40,000 rupees, if I make a EFI system of 30,000 rupees, nobody will buy that. So the big challenge which will come across, that is I have to give a very advanced technology at a very low cost. That is again a challenge, where innovation has to take a very important role. So some limitations of carburetor, again I can just summarize. As we have discussed, that engine has to operate under varying load and speed conditions. Carburetor is not suitable. Poor atomization of the fuel, because the pressure is very low, it is atmospheric. The atomization of the fuel is poor. If atomization of the fuel is poor, mixing will be poor. If mixing is poor, combustion will be poor. If combustion is poor, your performance, your fuel economy, your emissions will be poor. And just a typical example. A Maruti 800cc engines need only 3.3, around precisely 2.98 milligram of fuel per cycle per cylinder. If it is 2.8, it has gone out of the limit. If it is 3.2 milligram, again your emissions or your performance or your power will change. So to control this quantity very precisely under all dynamic conditions, it is not possible for a carburetor. I can tune a carburetor. Suppose I can tune a carburetor at 50 km of speed, constant RPM 2000, it can give this quantity. But whenever I change the speed and load, carburetor cannot handle this dynamic response. And that is the limitations of the carburetor. Beside this, I already told you, in multi-cylinder engine, not in single cylinder, because carburetor is at the center, I have to give the fuel to all the cylinder. The mixture distribution is not uniform. Cylinder number 1 may get different, 2 may get different, 3 may get different because of the length. Complete fuel cutoff during deceleration is not possible. This is a very important aspect which I will discuss with you. When you are running at a speed of 90 km or 80 km per hour speed and you want to retard the engine at that time because you want to reduce the power and your carburetor is still giving the fuel, I don't need that. What I want that, I may be applying brake, so I should develop a strategy. I can cut off the fuel during the acceleration period. What will happen? My fuel economy will improve, my braking effort will be low, and my emissions will be at that time will be 0. Last week we were testing a 3-wheeler because we have converted a 3-wheeler on a electronic fuel injection system. That vehicle is on road, has covered around a few thousand kilometers, but we are calibrating that, we are checking on a chassis dynamometer, and it is observed our emissions were very low. We have seen that when you are using the carburetor, during deceleration, fuel is still coming. At that time, during IDC, during Indian driving cycle, when you check on the chassis dynamometer, that emissions count a lot, around 30%. By reducing, by cutting off this fuel supply, you can cut off the, because there is no fuel, no combustion,
no emissions. And because you want to retard the speed, but again the important strategy is till how long I should cut off the fuel. Suppose the engine RPM are 5,000. Now this is very important control strategy and logic. From 5,000, speed will come to 4,000, 3,000, 2,500, 2,000. Then I have to restart the fuel, so that the driver should not feel the jerk. He should know. He should not be aware about any jerk. So that is a tuning, that is a calibration. And even that is a strategy and logic which we have to develop and put in the software. I think we will continue by keeping in mind the background of fundamental requirement of the engines. What is the engine? What is the basic need of the engines? We have discussed it is the amount of air, fuel. Then we have discussed what is stoichiometric air-fuel ratio. Then we have discussed what are the effect of the air-fuel ratio on power. What is the effect of air-fuel ratio on fuel consumption? What is the effect of air-fuel ratio on
Yes, sir.
emissions?
Sir, actually, Institute. Okay.
So it means we can conclude that air fuel ratio has a significant effect on engine performance, like fuel consumption and power. Similarly, it has the effect on the combustion characteristics like flame speed, combustion temperature and combustion pressure. And then we know it has the significant effect on the exhaust gas emissions like hydrocarbon and NOx emissions, right? And we have also seen that throttle body is not able to, carburetor is not able to meet all these varying requirement of different air fuel ratio and ignition timing under different operating conditions.
Sir,
Okay, now little bit we have discussed about the air fuel ratio. Another important point was about the ignition energy. We have discussed, right? Let me brief you about the ignition system also. Actually, what happened earlier, what we are using, there is a contact breaker point. You know that ignition energy required during the spark is around 20,000 volts to 30,000 volts. Okay. And that voltage, because your battery source is at 12 volt, so that voltage is converted into that 20,000 volts by a ignition coil, right? And in that case, there is a primary winding, there is a secondary winding. In the primary winding, the current flows around approximately 2 ampere. So 2 ampere current is flowing, and then with that current, number of coils, number of turns on the coils are different on the primary and secondary. Wire size is different and number of turns are different. So which is helping in producing the high voltage, lower current, because energy cannot be created nor be destroyed. So if voltage is 12, current is 2 ampere, so current will reduce in the secondary and voltage will be very high, because you need a high voltage to jump across the electrode. So you need to create the spark. Now what is happening? So next time we can make here more sometime you make a, so what is happening, like if when I'm making that contact breaking open and close, so suppose 2 ampere current flow through this contact, and when I am closing it the current flows, when I am breaking it the current stops. So when this is happening, when it is opening, the spark take place and the pitting take place. इसलिए आपने देखो पहले they were just with the emery paper, they are making this and they are making this contact. Now, to avoid that, we have introduced electronic ignition system, which are known as capacitor discharge ignition system or transistorized ignition system. So that is electronically controlled. So that will be also the part of the engine management system. So we have to control the appropriate quantity of fuel at appropriate time. At the same time, we have to control the ignition timing also and ignition energy also. These are the emissions. Just to give you a background, if you see, earlier we have the Bharat stage 1. This was introduced.
Sometimes we use a condenser in battery ignition system.
In battery
Ignition system.
Mhm.
After the ignition coil, we use condenser also.
Mhm.
What is the purpose of that condenser?
Condenser to avoid that spark, so that it absorbs the spike of that spark. That is the purpose of that condenser. When it is opening and closing, it creates spark, so that during that time it can absorb the voltage and it store that energy, and when it requires it, give that energy. So we are putting a condenser across the breaker point. BS1 is Bharat stage 1 emissions norms. We can make it Euro 1 also. And these norms I am just giving you for the cars, because like that there are slightly different norms, but you have to understand the philosophy of the emission norms. So we have the BS1. It was introduced in around 98. Then we have the Bharat stage 2. It was introduced in 2000. Then BS3 was introduced in 2005. Then BS4 was introduced in 2010 in cars. Okay. BS4 in motorcycle is introduced in 2017. In March or 1st April it will be introduced. BS4 in motorcycle and three-wheeler. And in 2020, we are introducing the BS6. So if you look at, when we are gradually increasing from BS1 to BS4 and BS6, your emission norms are, CO is like earlier it was 2.7, now it comes to 1. And in BS6 again it is reduced by 50%, maybe 0.5. HC is also reduced, so NOx is also reduced. So there is a significant reduction in the regulation to control the emissions. And why we are controlling the emissions, I think you all can understand now. Most of the newly born child in metropolitan city, they are facing the asthmatic problem. They are breathing related problem because of the air pollution. So air pollution is at alarming level. Recently, you might have seen in Delhi, your emissions are 7 to 8 times higher than the safe limit. So we are living in a gas chamber. So what I will do with that technology, which is killing my next generation?
In Beijing, it's spending one day in Beijing is equivalent to smoking 21 cigarettes.
Cigarette. So your life is reduced. So it is a sort of a slow murder. Because immediately it is not killing you, but it is killing you slowly. I am surprised because whenever I visit any family in NCR, small kids, 3 months, 5 months, 6 months, 1 year, they cannot breathe. Every mother has to give puff to them, inhaler. See, and even that is harmful for them. Is the technology is for that purpose? Certainly no. So we have to balance out the things. So that's why now we are going for partial zero emissions, and BS6 is in that direction. Even due to all these things, actually we were supposed to go for BS5, but Supreme Court, they say no, because emission is at alarming level. They say we have to jump directly to BS6 so that we can save this our planet. We can save the humanity on this ground. Otherwise, technology will be there. There will be no human being to to take that technology, to use that technology. If the emissions and pollution is not controlled, the stage may be expected in 2040. Either you breathe or you drive. It will be so alarming. So we are expecting a lot from young engineers like you, because you may be there at that time, and you can train your students, and you can really focus during your talk that pollution control is a prerequisite for survival of the next generation. And the technology which we are talking today, that is a one step ahead in curbing that emissions. Now, in future engines, I can do that. But again, the question arises, what is the existing vehicles? What about the existing engines? So for that also, government is making certain rules that you cannot register your vehicle after 15 years. You have to discard that vehicle, or after 10 years. Now I think it is around 15 years and they want to reduce it to 10 years. You cannot use the vehicle for more than 10 years. Yes, gentlemen. Now we really start with the multi-point fuel injection system or electronic fuel injection system. Now you can categorize this system into 4 subcategories: air intake system, fuel delivery system, sensors, and engine control module, which is the brain of the electronic fuel injection system. If you look at the air cleaner, as I was discussing you, this is sort of a air cleaner element, and this is paper type. And you know, all this pleating white has been done to increase the surface area so that you can hold more and more dust. And there is a mesh also. This mesh avoids the damage of that paper, so that when the air is coming with pressure and high velocity, it should not damage the pleats. So this is a air cleaner, and from here the air is passing to the intake manifold through the throttle body. This is that throttle valve which I was talking about. So when it is opening, it allows more air. When now it is closed, so it allows very little air, maybe 10%. And this position is equivalent to at idling. So as we have discussed, air filter, it prevents the dust particle from being drawn into the engine, as a result to help reduce the internal wear of the engine. If you start an engine without air cleaner, can you imagine what is the life?
Okay.
Engine life will be reduced to only few hours as compared to 1,000 hours. It will, the life may be completed in even only in 1 hour. It will be totally damaged. So from 1 hour, nobody wants that his engine is killed in 1 hour. So this is a very important component, and don't take it lightly. It is, whenever, you know, many times, so that audience and participant can remember all these things. Air filter, you can assume like your nose. You see there are small hairs in your nose, and some liquid is also there. So that actually trap the dust particle. So that's why I'm saying always you can inspire from the nature. And intake system design of the engine, I tell you a real story. We were working earlier, you know, there are only 2 valves in engine, one intake valve and one exhaust valve. So in intake, through intake we are inhaling, through exhaust we are exhaling. Now, because as I have discussed, air is the most important parameter, not fuel. It is the air which decide the power, which decide everything. We thought that how we can increase the volumetric efficiency.
So there was one passage. So idea was we can make it two well intake. So instead of one, we have two. We can draw more air to the engine. And two exhaust. So it is a 4-valve technology. Okay. And first time we have introduced this in Maruti also in India. But there are other engines also, Honda and all that. They are 4-valve engines. But most of the motorcycle engines are 2 valves, one intake, one exhaust. So anyway, for the sake, then we started the designing, because when you have the 2 intake valves, so through the intake manifold, you have to connect it. A lot of simulation has been done, computer simulation, when the flow will be maximum, when I can draw what type of design I make, so that like suppose it is the intake pipe, it is coming from the air cleaner side. I think I can just, if there is a picture, I can just, yeah. So this is the air cleaner, okay. Air is going in, and here it is entering, and here it is entering into the engine. So this is the intake manifold passage, right? And now it has a one valve. If I am making 2 valve here, are you understanding me? Then this whole passage has to be redesigned and optimized. And the shape of that is very important. So after 6 months of simulation, when we started making the prototyping, you know what type of design comes out? The design was like a nose. Nose is white, like there are 2 intake and they are merging in one. The shape of our intake system. So this is the best design. The nature has designed in such a way that you can inhale maximum air with little bit effort. Very little effort. Because if the shape will be like this or like this, you would have put more effort in inhaling the air. So your intake system is like your nose. So there are air filter, your small hairs are there, they filter out the dust, and then the flow should be without any restrictions. So this is what air intake means. Now I was talking just for your another function of this is, as I have discussed, you dust holding capacity, how much dust it can hold before the terminating pressure drop. Another important aspect is it also damps the air noise, because every car or motorcycle, it has to meet the bypass noise regulation also. The noise of a vehicle or a car should not be more than 72 dB level. If it is making more noise, it is not passing the regulation. So noise regulation is also you have to meet. If you remove the air cleaner, even many cars, along with the air cleaner, they are using a resonator also. The purpose of the resonator is to dampen the high frequency and low frequency noise. So that is designed for that. So that you can meet the noise level regulation. So it also helps. You remove the air cleaner, you see engine become more noisy and like that. Good design provide more area of filtration. Like I told you that pleats are there, number of pleats. There is the number of pleats, depth of the pleat, dia. All these are the design parameters. And pressure drop across the new air filter is around 1 kilopascal approximately. And as it become older and older, as it accumulates the dust, the pressure drop is increased, and the terminating pressure as a design parameter, I can tell you, it is around 4 to 5 kilopascal. If the pressure is increased to 4 to 5 kilopascal, I should remove the air cleaner and I should clean it, or I should put it back. And filtration efficiency. Very interesting thing. One more thing I am going to tell you. Do you know that generally if you buy any product, their efficiency, if it is a new, efficiency is more. Maybe after usage of the time, the efficiency is reduced or increased? Huh? Reduced. Do you know any system where after usage the efficiency is increasing? No, engine efficiency is reducing. That's why after 2 lakh kilometers we are overhauling the engine, it is totally scrapped. the component which we are talking about, air filter, the cleaning efficiency of the filter when it is brand new, it is around 98.5% or 98%. And when the dust is accumulated in that, the pore size is reduced and cleaning efficiency or filtration efficiency is increased, but at the cost of higher pressure drop. Are you getting me? But if, because the function is clean the air, older cleaner, air cleaner give you better cleaning efficiency, but at the cost of high pressure drop, at the cost of poor engine performance. There are three categories of filter. One is the air filter, fuel filter, and oil filter. In all this filtration system, their filtration efficiency increase when the filter is becoming older, dustly, because the pore size, suppose it is 20 micron, that will reduce to maybe 10 micron. So it will increase the filtration efficiency. One interesting thing also I am going to tell you, even in Euro 6, even they are making the filter. Now you can say, okay, my filtration efficiency should be 99%. But my dear, now they are breaking it up. They say filtration efficiency. Suppose if I use a dust particle of 2 micron size and the pore size is 10 micron, the whole dust will go inside? No. So the cleaning efficiency is meant for what particle size? That regulation is, that design parameter is also coming in Euro 6. So it is not a common filtration efficiency. It is that filtration efficiency for 20 micron particle size should be 99.9%. Filtration efficiency for 5 micron particle size should be 40%. Filtration efficiency for 3 micron particle size or 10 micron particle size should be X%. Because if the air is going, along with that, it may be 1 micron, it may be 2 micron, it may be 10 micron, some size will go, depending upon the size of the pore size of the filter media. Because more and more advanced the technology, more and more cleaner fuel I need, more and more precise control is required. So air filter, you see, when you are talking about BS6 or Euro 6, you see, is only EFI, but EFI means each and every part you have to redesign. Okay, so this is what, and for that we are using a nano technology. Mahalle company has developed a filter on nanotechnology. You cannot see that, and pressure drop across the air cleaner will be very low, and the micron size they can filter is up to 5 microns. That is with the help of nanotech. So future is also with the nanotechnology. The type of filter, as there may be side mounted, central mounted, then it is a paper type. Somebody was saying oil is also we using, so we call it oil bath filter. So now with this air filter system I have covered, is it clear to you? So what is the purpose of the, it is like a nose, like I have the hairs in my nose, so it removes the dust particle from the air, and important parameter is how much dust it can hold before the cleaning, that is dust holding capacity. There are two other parameters also. Filtration efficiency, the filtration efficiency of the air filter should be minimum 98.5% or 99%, and the terminating pressure drop is the pressure drop across which I should remove the. Even in advanced vehicles, as I told you, that I am putting a pressure sensor which gives me the delta P across the filter. If the pressure drop across the air cleaner is limiting that, a alarm will come in the vehicle, please change your filter, or a light will blink. Because you, a user, you don't know when he should clean. He will just follow the condition, okay, clean it after 5,000 kilometers or 10,000 kilometers. But my dear, that 5,000 and 10,000 is not very true situation, because it depends under which driving condition you are driving your vehicle. If you are in Rajasthan, in dusty area, the 5,000 may not be true. You have to clean your air cleaner in 1000 kilometer. The real aspect is what is the pressure drop across the air cleaner. So it is a very generic statement that clean your air cleaner after 5000 kilometers. It is very generic statement. Are you clear? Okay. Now, can I move to the next point? It is a throttle body. Now, throttle body, you see here. Now, air is coming from this side, from the air cleaner side, right? Can you see this arrow?
Yes, sir.
Air is entering here, and this is the throttle body. If I open the throttle body more, then it will allow more air, and this is going to the engine. Now, very important aspect here for Euro 6 point of view. Number one, in Euro 6, hydrocarbon emissions, generally, one thing you should know, why CO is formed, why hydrocarbons are formed, why NOx is formed. Because when I know the reason, when I know the root cause, only then I can take some countermeasure. If I don't know why CO is producing, how I will remove it, how I can reduce it. So CO is mainly the function of the air fuel ratio. As I had told you, hydrocarbon is produced due to the quenching effect of the flame, and it is mostly produced at the walls of the cylinders. The surface area, which is cooler comparatively in the combustion chamber, because inside the combustion chamber the temperature may be 1000 degrees Celsius, but at the walls it is low. So when the flame is traveling, so it quench there, or area which is not exposed to the combustion. So with that, now what they do, earlier they say, even now in three-wheeler, they say, okay, you warm up your vehicle for 40 seconds. Even in two-wheeler, you can warm up your vehicle for 5 minutes. You can drive on the driving cycle for 5 minutes. They will not measure your emissions. They allow you. But sir, that is not true practically. With that emissions during that time also going to the environment. But regulations say, okay, warm up this, because the technology, existing technology was not suitable if you are measuring the emissions from the beginning. In cars, they have deleted that time. So we are not allowing you. In car also earlier 40 seconds was the time you can warm up your. So you start your car and keep 40 seconds on before taking the emissions. By that time, because now I am sharing with you a very important aspect. 80%, my dear, 80% of hydrocarbon emissions are produced during the cold start period only. During initial 1 minute. Total driving cycle is of 10 minutes. 80% hydrocarbon emissions are produced during cold conditions. When engine becomes hotter, hydrocarbon is reduced drastically. So what we do? It is a challenge. Whenever I start the engine or vehicle, I want that engine should warm up quickly, as early as possible. But if you don't know what is the root cause of hydrocarbon formation, I cannot take the solution. It means I can think now, what should I do to warm up the engine quickly? Say just after 10 seconds, engine is attained optimum temperature. So there I can utilize the waste heat recovery. I can use some concept which help me in attaining the high temperature. And with that, another thing, suppose practically the problem which is coming, if you are going to Leh Ladakh or any cold conditions, this throttle, now this point you listen carefully. This throttle, when you are not putting the accelerator pedal, foot on the accelerator pedal, this position is like this. So when this position is like this, it will send around 80, suppose around 5 milligram of the 3 into 15, around 45 milligram of air it will send, just for example. And the data is very close to the real for 800cc engine. 45 milligram of air is going to the engine. Now, you have gone to Leh or any cold place. This throttle will remain same. You are not changing this throttle. But there, because it is very cold, you have to inject slightly more fuel quantity, and you have to also increase the slightly more air. And now by foot you cannot do that. It means there should be some mechanism which change the quantity of air as well as fuel. Fuel you can change by changing the duration of injection. With the issue, you can have a lockup table, you can do there. But how to do this? I have to increase, I have to control the quantity. I have not, because I am at idling. How I can make the system that my engine can take different quantity of air depending upon the temperature of the environment. For that, we have designed a idle air control system. This is little bit one mechanism, but now we have another, but you understand the system. What I will do, you see, I will set in this, suppose here 45 milligram air is going across the throttle valve. Now, can you see this? I have a bypass valve. Some part of the air will go from here, and then it will enter, and then it will come from here. And this valve, this I can control through the ECU based on the temperature. Suppose temperature is 0 degrees Celsius. You need 50 milligram of air. 45 milligram of air will pass through the throttle, and 5 milligram it will open such that it can supply the 5 milligram of extra air. And this is all a calibration. My dear, I tell you, calibration is a very peculiar art. Because if you touch one parameter, 5 parameters go out. If you touch one, so it involves a lot of experiences. Even the person I was in, we are supporting Hero Motor Corps, which is known as Hero Honda, because their R&D center is in Jaipur now. So we are training their whole team on EFI. There are around 38 engineers up to GM level. So we have started a course 3 months before. So we have signed an MOU with the Hero Motor Corps and training them on the how to design and develop a electronic fuel injection system for a motorcycle and single cylinder engine. Now their R&D head is from Austria, who is engine head, and he also said that we are struggling for calibration engineer. In India, there are only 3 or 4 calibration engineers, keeping in mind all Toyota, Honda, and all these things. Because real calibration, main calibration is happening overseas only. Here they are just doing fine tuning. And our engineers which are working here, they know superficial calibration. Because main calibration they do, here they do just fine tuning. So this is a subject. Knowing EFI system is one part. Doing calibration required around 7-8 rich experience in calibration. Only then you can little bit understand the ABC of calibration. And this part, in vehicle, I tell you, idling calibration is only one part. And this idling calibration, cold startability calibration, it takes 2 to 3 months, which I am telling you, complete EFI system in 1 hour or 2 hours. The one part, only idling calibration, I have to spend minimum 2 months on the vehicle to optimize it. Mass emissions, I have to spend 4 months. Drivability, I have spent 2 months. And then hills testing and all that, another 1 month. So it is a complete job of approximately 1 year. Calibration. After, when my system is working, it is so peculiar. And not only, suppose you have done on one vehicle, very, very challenging task. Sir, in production, I have to produce 1 lakh vehicles. The tolerances are there. Engine compression ratio may not be same identical because there are tolerances. Injector flow rate, which I have used. The injector making person, he cannot give me the injector of the exactly same flow rate every time. If the flow rate spec is say 160 ml per stroke, it may vary plus minus 1%. And if you look at the engine parts, all temperature sensor, map sensor, injector, ignition coil, is you all having the tolerance. If you consider the tolerances of all, my calibration may go haywire. So what we have to do, it is very challenging. I have to make 3 vehicles. 1 vehicle I have to make by considering the lower limit tolerances, which will make my engine, if the condition, if injector flow rate is low, oxygen sensor is at lower value, all I can make. Another limit sample I make when the limits are on the higher side, and 1 medium. And to making those limit sample, it is very challenging. I have to select, I have to tell that person, okay, give me these limits. And it is 1 knot part. In engine, I am using around 300 parts. All 300 parts, even piston rings, I have to consider all these things. What will the compressions of the lower side? And those sample when so I am fixing the boundary condition. It means I am developing a vehicle and engine, considering that one is extreme in that limit, one engine is and vehicle is extreme that limit, and then again I have to do the final calibration so that whatever type of component will come in this range, it should meet my BS6 emission. Now can you imagine how much challenges it is? Even catalytic converter, precious metal, that is also a limit sample we have to do, because the loading again it may change, process parameters may change, little variation is always there. So this is a very, very typical phenomena. That's why not only in India, in world level, you can count calibration engineers. They are not more than in hundreds. In world level, I am talking about, who understand the calibration. So this ISC valve, this is very important. And cold startability, again in a car, suppose you switch on the AC. If you switch on the AC, you are not supposed to press the throttle at that time. When switching on the AC, load is more on the engine. Engine should be sent more air and more fuel. Again, who will send the more air? You are not pressing the throttle at that time, and neither you can do that. So automatically it is taken care by idle air control valve. So idle air control valve technology, you can do 10 PhD, 20 PhD, 30 PhD only on these reasons. देखिए मैं आपको बताता हूँ, when we were in undergraduation, when we have done our graduation, we thought I know each and everything. I know thermodynamics, I know fluid dynamics, I know drawings, design, theory of machines, I know all properties, materials, metallurgy. You can ask anything. We were thinking like that. When we have done masters, we know something. And when I was in PhD, I was doing only on engine and engine management system. Then I realized I do not know anything. And when I went for postdoctorate in Imperial College of Science and Technology, London, then I found that I am totally ignorant. There is so much to learn, hardly I know anything. So today, the statement is taken as an expert They say there is expert. Really, I am telling you, I am not expert. I know very little about the engine and engine management system, because there is so much that I have realized after doing my postdoctorate and after 20 years of experience of industry. I can say now that I know very little. And I was in the impression when I was fresh graduate, I know each and everything. Okay, because when you go at micro level, then you will think that there is so much there. Even what I am talking about, even ISC, the design of ISC wall itself is very critical, because you have to control the flow from 1 liter per minute to 400 liter per minute, and controlling the airflow very precisely is a very challenging task. The sealing of that, the control of that, controlling mechanism, when you design it, make the difference. Now, one type of idle air control valve I am sharing with you. It is very simple. It is stepper motor type. So, stepper motor means when you are just giving supply to it, number of turns, it moves forward. So it is opening and closing the air passages. And this is you can see when valve steps are increased, airflow will increasing. So by moving the steps, this type of valve I have used, we have developed a engine or 800cc engine on LPG in Maruti. So we have used this type of valve, and the motor has 218 number of turns, and in 218 number of turns it moves around 7 mm. So per turn you can calculate how much movement is there, and from there you can do all the calculation of the airflow. My dear, this is, I am sharing you actual flow rate of cars. Here you can see duty ratio. Duty ratio means if my air control valve, if it is fully open, it is 100%, and if it is 50% opening, it is 50%, it is 60% opening, 60%, and around below 15, it is almost closed. So you can see, when this is the test bench data, when we design, we find that at 100% duty ratio, the flow is around 400 liter per minute. Now, two colors are mentioned, pink and dark blue. Upper is the maximum limit, because if I am making a mass production valve, so if I am making 1000 valves, so all the data came in between the flow rate data. This is the production variations. When I was talking about that production variation, this is what limit sample means. Means I have to take one sample of this and one sample of lower minimum flow rate. And this you see here, what I have done, when we are making the car, just car come out of the plant, we check all the parameters. So this brand new car, which is clocked 0 kilometer, which is just taken the birth, I have checked all this. These are the number of vehicles. We have checked around 50 vehicles. In all the 50 vehicles, you see duty ratio at idle is varying from 18, between 10 to 18. So there, what the purpose is, we have the diagnostic tool. I will set that during idle air, the duty ratio may change from 10 to 20. If it is more than 20, it will indicate the fault. But before that, I have to check like this 1000 vehicles to identify that, because if I have set suppose 15 and the vehicle comes at 20, so it will fail in that. So this is a very important exercise. You see, the whole car, I am using the same part, same design, everything is same, but it is, you see how it is varying. Car to car duty ratio. Theoretically, it should be same. Am I right? because I am not changing the engine, I am not changing anything, but it is the variations. So this is the idle air control valve. So idle air control valve is useful whenever you are switching on the AC or you are switching on electrical load. Suppose you are switching on the headlights, electrical load increases, power from where it is coming? Engine. Or you are in cold condition, due to the temperature variation, it will compensate, and any load during idling, it is compensated by the idle air control valve. Is it clear? Now with this, I think I have covered the air intake system. Duty ratio ये है, like if suppose wall is I am supplying 12 volt and then I am supplying 6 volt. At 12 volt it is opening 100%. At 6 volt it is opening 50%. So duty ratio is जितना आपने खुला है जितनी उसकी capability into 100. That is duty ratio. Fuel delivery system. I have to move a little bit faster because there are 3 chapters which I have to cover because I am going more deeply. That's why it is taking time. But there is a lot of things to cover. Fuel delivery system, like you can see a slide. It is a fuel tank. Then we have a fuel pump. Then we have a fuel filter, and then we have a fuel injector. And we are injecting at a controlled pressure. So generally, pressure fuel injected at around 2.9 or 2.8 or 3 bar pressure. In motorcycle, it may vary, like Yamaha is planning to inject at 2.8 bar. Hero Motor is planning at 2.6 bar. So it is the design parameters, but it may vary from 2.5 to 3 bar. You can note down this. The fuel injection pressure generally is 2.5 to 3 bar. In car, it may be 3 to 4. So this fuel pump, as I was discussing you, at this moment, we are using a constant speed pump, electrically operated. It is operating at 12 volt and it supplies the appropriate amount of the fuel to the engine under all operating conditions. And my limitation is, for a bike, I am using a fuel flow rate of around 40 liter per hour. And bike never use that because till now, there is no variable fuel pump is designed in all the cars. So they design what is the maximum flow rate the car need, and if it is in idling, maximum fuel comes back to the tank, which is a wastage basically. But they keep the flow rate and RPM of the pump constant to avoid any complication in the design. But there is maybe a need to design a variable speed fuel pump. But all these things we can understand when we are going deeper and deeper. But when I realized, like I am giving an example of, suppose Swift car 1.3 liter, the flow rate is around 80 liter per hour. And the maximum requirement never go more than 6 liter. So the fuel flow rate is 70 liter extra. Why? Because I have to maintain the pressure, and secondly, I have to design, because I cannot reduce the flow rate. I don't have the variable speed pump. But now we are trying for a variable speed. So if it is in idling, suppose requirement is 1 liter. In idling, approximately you need 1 liter of fuel per hour, for example. And when the engine is running at full load and full speed, you may need around 12 liter. So my requirement is 1 to 12. And I am using a pump of 60 liter or 70 liter. So I am consuming more power. And when it is at idling, it is too much excessive fuel, it is returning back. And what is the problem again? If the fuel is going to the engine compartment, there it absorbs the heat. And when it is going back to the tank, the temperature of the fuel rises. Your evaporation losses increases. The temperature of the fuel tank, can you imagine, it goes up to 65-70 degrees Celsius because of this. Then they find out another solution. In the pump itself, they put the return circuit. The excess fuel will come back, short circuit there. But then it causes a vapor locking problem because the fuel which is going there is no return circuit. And when you switch off the car, the fuel is there, and when it is heated up, vapor is forms. That causes vapor locking. it give you trouble in summers. So for each and everything there are, but the best way is I supply less fuel. Right. So this is another thing. Now come to the parts of this fuel system. You have a fuel pump, you have a fuel filter, you have fuel pressure regulator, delivery pipe, and fuel injector. So this is a operating range in India. Now again, very interesting story. You know that CLO car, Martis and CLO, the Dev has launched. I think they were the first peoples when they have launched EFI system in 99. And many cars are standing on roads. There are a lot of challenges. What happens? Because the technology is designed somewhere else, keeping in mind the environmental conditions of that particular country. So Hyundai, they have designed for as per the Korea or Japan. So the pump which they have designed, that is capable to withstand around 55 degrees Celsius temperature. In India in summer, the temperature go up to 65 in the fuel tank. The pump fails. They were not, because if suppose you have purchased the car, you don't know what is happening. You know the engine is not started. You don't know fuel is coming or not, what is happening, you don't know. Consumer don't know. So when he is starting that, he is not able to start because the pump which is mounted in the fuel tank, it was designed for a temperature of operating temperature of 55. Then we have redesigned that pump. Then another problem, then we have launched the EFI system in Maruti in 2000. We face a lot of problem in injector, lot of problem failure in pumps. The reason of that is due to the poor fuel quality. The pump fails because there was more sulfur and there is a shaft. You know, I can show you the, if here, this pump is sort of a rotary pump. Can you see this? So here there is a shaft, and when your car is standing, so the sulfur in the fuel that start depositing on the bearings. So the audio of the bearing is reduced. The shaft which is rotated in it, the tolerance becomes less and it becomes tight. It is difficult to rotate the pump. You know, even problem analysis, you require a deep analysis approach, because whenever any things fails now you are looking at the vehicle at that time. First you have to pinpoint where the problem is from the vehicle, whether it is in the engine, whether it is in the piston, whether it is in the spark plug, where it is in the ignition. Because first you approach to the pump, you are able to arrive there. And if pump is there, then you have to, there are maybe around 80 child parts in this, which causes the problem. So this is the problem. Another point, when there is a winding is there, that copper wire is there. If there is a acidic nature of the fuel, it eats the copper. It will not allow the current to pass through. So again, we have done the modification in the pump. When the Swift diesel was launched, the pump was from Germany. So we asked them, okay, because we expect that it should meet around 20,000 kilometers of, 20,000 hours of reliability. They say, okay, we have done in the Germany and it is there. You told me we don't want that it should meet the reliability in Germany, because fuel you are using, which is available in Germany, my fuel quality is different. And even my fuel quality is different when you are getting it from Rajasthan, from Punjab, from Jammu, from Kashmir, from UP, from Chennai. Fuel quality is varying from petrol pump to petrol pump also. So what to do? Either send the fuel from here or get it tested here. So these are the very important aspects when you are developing a vehicle and when you are putting it on road. and to address the issue of the local environment. Because I know in my country, there is a possibility of adulteration of the fuel. I know this. Another problem we observe, many problems come from the Bangalore. What is the problem? There, the people are mixing even water. Water contents were very high in petrol. So injector, that plunger is there, it got rusted and it is not moving. The vehicle not started. Then we cannot ask that you don't mix the water because you cannot control the 120 crore peoples, but you can control your technology. Then we have developed we have changed the material of that needle. Problem sorted out. So that's what, whenever you are developing the technology locally, then you have to make a lot of changes depending upon the environmental conditions, depending upon the fuel availability and fuel quality also. The pump is very peculiar part of the same. And we have fuel filter. All we know, however, there is a mean pore size, which I was talking is 8 to 12 micron. Actually, there is a lot of things in this also, but I'm just broadly I'm telling that efficiency should be more than 90%. Flow rate is varying from 40 liter to 80 liter depending upon the capacity of the engine. Then we have the pressure regulator, which is able to supply the fuel at constant pressure. It regulates the pressure, and generally it is the design parameters. You may make it for motorcycle, generally it is 2.5 to 3 bar, 2.8. It depends upon the designer, but range I am just telling. So this is the principle of operation of the pressure regulator. You have a diaphragm. If fuel is excess, it will be released back to the tank, and only appropriate pressure is maintained at the tip of the injector. I will be little bit faster because of the because there are a lot of things to discuss with you. About injector, I have discussed. This is a sort of a solenoid valve. We have the winding. I may have the cut section of this here. Now you see, it is at this moment there is only one company which is manufacturing this injector in India. That is a Denso, because you need very high volumes in millions to make it viable for the production. And when you are manufacturing this injector, you need 7 grade cleanliness level. 7 grade means like a OT where doctor is operating you. Even the person who are assembling, you are not able to see their body part. Complete head is covered, eyes, mask is there, hands, everything is covered. No body part is visible when we are assembling the injector and testing there. Because even during assembly, the size of the hole where the fuel is injected, it is in micron. And if smallest particle, suppose that size is 18.8 and dust particle is settle of 0.9, so it will block that. So your injector at the assembly itself is failing. So this is a very, so here, although I have used, there are 3 grade of filtering I am doing. One filter I am providing at the fuel pump, which is, we called it suction filter. Then I am providing one fuel filter, which we have discussed in the line in between. And third filter you can see, before entering to the injector, again I am providing a filter. So 3 grade cleaning is there, so that you are at different stages, different micron size, you are holding the dust. When this fuel is coming, this is entering here like this, and you can see this is the coil. When you are sending the current to the coil, it energizes and it pull this needle. It lifts the needle and fuel is all around this, and fuel is injected through this hole here. This is the nozzle plate, and in nozzle there are small holes. Now again, the number of holes may be 1, number of holes may be 2, number of holes may be 3, number of holes may be 4. It depends upon your spray pattern. Even this is a PSD. you can do 100 PhD in this area. Only optimization of the nozzle and spray pattern. So because spray pattern, the engine told me, okay, your spray angle should be 15 degree or 20 degree or 30 degree or 40 degree. Location of the injector, orientation of the injector, spray angle of the injector, they play a very vital role in mixer preparation. So injector is clear. This is the cut section. This is a real cut section of an injector. And the operation, this is controlled by the ECU. It opens and closes. When the current is supplied, it will open. When current is not supplied, it is closed. And just typical example, there are these 4 parameters are very important: static flow rate and dynamic flow rate. Do you understand what is static flow rate and dynamic flow rate through the injector? Static flow rate is, I am opening the injector for 1 minute and I am collecting the fuel in 1 minute, how much fuel it is able to inject. Dynamic flow rate means for a 1 minute, I am not operating continuously. I am giving pulse of 2 milliseconds. Open, close, open, close, open, close, open, close, open, close. But actually in the engine, it is a dynamic flow rate which matters. But from the complete capacity of the injector to know, I have to go for the static flow rate. So that is for this injector typically 175 cc per minute, and dynamic flow rate is 3.6 millimeter cube per stroke, and stroke duration is 2 milliseconds. Spray angle is 15 degree. It may vary from, I told you, from design to design, and the number of that in this is, it may be 1, it may be 2, but now we have the 4 hole injector also. Now, I think it will be clear to you, when I am giving any pulse from the ECU, it will open the injector for a certain time, which may vary from 2 milliseconds to 10 milliseconds, depending upon the load and speed on the engine. And this, at what time it should open, that is the start of injection. For how long it open, that is the duration of injection, which is in microsecond or in millisecond. And this is what to be calibrated. Now, again, there is an important strategy, because when your engine is, suppose you came in the night, you keep your car in the parking, when in the morning you are starting your car, one is temperature is low. Another thing is, to start the engine, I want engine should be able to start as soon as possible. Because if it is taking 3 or 4 revolutions even without firing, all the fuel will go unburned, and that will increase your it is pure hydrocarbon going. So there is a regulation that your engine should be able to start within some milliseconds. And to beat that challenge, now when you stop, your piston may be here, your piston may be here, your piston may be here, and your piston may be in intake, your piston may be in exhaust, your piston may be in compression, your piston may be anywhere it may be. And suppose it is at an extreme level, so it has to complete minimum 2 revolutions to come to the back to that point. And ECU has to identify that. So you have to wait for that. So to avoid all these things, what we do to make it a quick start, we use a asynchronous injection. Asynchronous injection is, I am not using timed injection. Whenever engine start cranking, immediately I will inject little quantity of fuel. And when the time will come TDC, where I want to inject, then again I will inject appropriate quantity. And this I have to optimize very, very carefully. The idea is, I can start the engine in only 1 cycle or maximum 2 cycles. 1 cycle means 2 revolutions or 4 revolutions. We have checked the startability, and in MPFI we are able to start the engine in within 400 or 500 millisecond, because cranking RPMs are, do you know what is the cranking RPM of an engine? When I am cranking, engine is rotating at certain speed, that is known as cranking RPM, and that RPMs are around 400 to 500 depending upon the vehicle to vehicle, or broadly it may be 3. Okay, now can we start?
Yes, sir.
Now we will start when and how we are controlling the injection. So there are two factors very important. Number one is what we call it basic duration of injection. We call it a basic table. Based on the air flow requirement, what is the air going on, we calculate what is the amount of fuel is required. Then based upon the injector characteristics, we know this injector is capable to deliver 2 milligram of fuel in 2 milliseconds. And suppose requirement is 3 milligram. It means 3 millisecond is the duration of injection. So that we call it very basic. This is the start injection duration, basic. Now this is not sufficient. Very important thing is happening when you are cranking. What happened during cranking? Engine तो start ही नहीं हुआ अभी. Your injector is there, ECU is there, pump is there. You ignition on. Switch on the ignition. When you switch on the ignition, then you start cranking. Cranking means you are trying to rotate the engine with the help of a starter motor. That is the cranking. When you start the cranking the engine, the starter motor is drawing very high amount of current. That is in the order of 100 ampere. Because it draws very high level of current, because it has to rotate the complete engine. Because engine is idle. It is not moving, it is stationary. So to rotate the whole mechanism, you need lot of torque and power. That is provided by the starter motor. Now when the starter motor is providing, it draws very high current. From where it will draw the current? From the battery. When it will draw high current from the battery voltage is generally 12 volt. That voltage drop down. This is a very, very peculiar behavior. When the voltage is pressed down, it means your pump and injector, the flow rate characteristics are designed for at 12 volt. When the voltage is dropped, suppose a injector, when you provide 12 volt in 2 millisecond duration of injection, it injects 2 milligram of fuel. But when the voltage drop is suppose 10 volt, the quantity of the fuel to be injected will reduce. So during cranking, it is a different behavior. I know it will, suppose I tell you, during cranking, due to the voltage drop, the fuel quantity will reduce by 10% in the same duration of injection. So then I have to provide a correction factor for this during cranking. Get me? And this is what the battery voltage compensation. So I will continuously monitor the battery voltage. If the battery voltage is low, and battery voltage may be low due to any reason. Sometimes battery voltage is low because of the life. Sometimes battery is discharged. Sometimes due to any reason. So there is a correction factor which is known as battery voltage correction. So if the voltage is low, or sometimes voltage may be higher than 12 volt, because when the charging system is there, the voltage is around 13 volt or 13.5. So at that time you have to again apply the correction factor. So basic duration of injection is what is this one. Okay. Then voltage correction, this red one. And this is a correction coefficient which may be due to the air temperature.
because as we have discussed a lot, when the temperature of the air changes, air density changes, mass of air will change. Accordingly, quantity of the fuel to be injected will change. And to make that change happen in duration of injection, this is the correction factor, blue one. So final duration of injection will be this plus this plus this. Clear? And like this, there may be more correction factor also. Like there may be a engine coolant temperature, there may be a intake temperature correction also. There may be a, you can add atmospheric pressure correction also. But these are the correction factors. So final duration of injection is equal to base duration of injection plus correction factors. And correction factor may be due to any reason, like battery voltage, like air temperature, like coolant temperature, means engine temperature, maybe on depending upon the atmospheric pressure. It is the same thing, voltage correction. Why? The injection volume and rate of opening of depend on the applied voltage across the injector. If voltage is low, opening may change, right? This is what we are calling, and hence this voltage correction factor is implemented. This is the fundamental behind that. Now, normal injection volume. This is about the calculated injection duration, base injection duration, correction coefficient, voltage correction. What we have discussed with you. Now, correction coefficient. There are different things. Very important. First is when we are cranking. I need, you know, earlier you were providing a choke to start the engine in the early morning or in the winter. Now there is no choke in EFI system. What the choke means, it is making the mixture rich. So there is a enrichment circuit, enrichment strategy. The first thing is what I am writing, start enrichment. And there may be a cranking strategy also. During cranking also, you need a strategy. When it is started, warm up enrichment. That, like I had discussed with you, in Euro 4 or in Euro 6, we want to warm up the engine as quick as possible. Normally, a engine take 5 to 6 minutes to warm up. Now, my purpose is how to reduce the warm up period. So this we can change, and there are two ways to do this. Number one, I make high idle. Engine speed I increases in the beginning, maybe 1800, and then as it warm up, I make it slowly reduced. And then when the engine is fully warm up, it may be 900 or 800.
One question. Sir, at the time of starting, consider I have shut down my engine and the piston is at bottom left center. But now I am starting the engine. How the process will be taken place?
There is a crank position sensor. So as soon as you rotate the engine, the ECU will get the indication when the TDC will come. Okay, so it means it will take some time to detect the TDC. That is in microsecond.
What is the in case of scooter and bikes?
It is same thing.
There is no EFI system.
Then you don't have the sensor, no? Then fuel will come with the carburetor. As soon as the airflow will take place, fuel will also start coming from the carburetor.
Means if we will talk about the diesel engine and how will the combustion take place at that time?
देखो आप confused हो रहे हो आप. We are not talking about the diesel engine. So don't make confused with the diesel, because again it is another subject. In diesel engine, I am not controlling the air. Air is coming in the engine. At the end of the compression stroke, I am injecting the fuel through the injector. In diesel engine, there is no carburetor. and the injector will give the fuel. It is governed by the camshaft. So camshaft is positioned, and timings of the camshaft is such that it should inject around TDC. So it is a mechanical arrangement. It will do that. आप समझ रहे हो? अब मुझे आपका ना क्वेश्चन भी समझ में नहीं आया. मुझे तो समझ में आपका क्वेश्चन ही नहीं आया अभी तक. What you want to?
My question was that at the time of starting, I'm starting my engine. My piston is at bottom dead center.
हाँ फिर क्या है वो जब टॉप बॉटम डेड सेंटर तो टॉप डेड सेंटर पे तो आएगा ना वो जब इंजन घूमेगा.
I'm starting. I'm just asking what will be the force that will pick the piston to up to the top dead center.
हाँ तो मोटर जो होती है क्रैंकिंग करते हो दैट विल प्रोवाइड द फोर्स. जब हम क्रैंकिंग करते हैं इन मोटरसाइकिल नाउ देयर इज यू कैन क्रैंक इट. इफ यू डोंट क्रैंक इट, आपने देखा ना किक नहीं मारते आप, दैट किक विल प्रोवाइड द फोर्स. नाउ देयर आर टू टाइप ऑफ बाइक. वन इज द यू कैन स्टार्ट द किक. So initial force, the movement, like anywhere the piston stops over BDC. So you make the kick. If you don't, that is a mechanical system. If there is no kick, you have the starter motor. So starter motor will push the piston in diesel as well as in petrol. In tractor engine, you might have seen there is a pulley and you put the rope and then you pull it. So there may be many means. In diesel engine also earlier the people were just being the mechanical. So you have to rotate the engine by external force. That external force may be provided by the starter motor. That may be provided by the kick. That may be provided by the rope. That may be provided by the human effort. Is it clear? Okay. Now these are many correction factors like we have discussed. Intake air temperature correction, I told you. Transient time air fuel correction. Now this is very, very difficult. Transient time means suppose your vehicle is running at a speed of 40 km/h and you are accelerating and you want to achieve 80. So from 40 to 80 it is continuously changing. So this is the transient time. So during transient time any parameter is not fixed, not constant. So regularly you have to change each and everything. When you are suddenly accelerating, air will increase suddenly, but fuel will take time because it is viscous. So there is a time lag between. Suppose the quantity of the air you have changed from 50 milligram to 60 milligram. Now to compensate that, you have to change the fuel from suppose 4 milligram to 5 milligram. Now air will change immediately. Fuel may take some time. It is a time lag. To reduce that time lag, we make the mixture overrich. So we put the fuel in extra quantity. That is known as transient air fuel correction. Power enrichment. Suppose you want to run at a 120 km/h speed. At that time, you need more power. More power means you have to make the mixture. If more power is required, what you have to do? You have to make the mixture. If the power requirement is more, you have to make the mixture. हाँ भैया, रिच वाले हाथ उठाओ. भाई जब ताकत ज्यादा चाहिए तो डाइट ज्यादा लेनी पड़ेगी या कम? लीन का मतलब है यू आर रिड्यूसिंग द फ्यूल. व्हेन यू नीड मोर एनर्जी, जो एक्सरसाइज करते हैं, सपोज आपने स्विमिंग की कंपटीशन की तैयारी करनी है और बॉक्सिंग की करनी है, तो यू नीड मोर एनर्जी और लेस एनर्जी. ऐसे याद रखना. इट इज नॉट लीन, इट इज रिच. इसलिए यहां पे लिखा हुआ पावर एनरिचमेंट. तो मेरे को उस टाइम पे क्या करते हैं हम? When we want more power, I identify the zone in the car. Like one zone is idling, one zone is moderate speed. आपने देखा कई स्पीडोमीटर पे ग्रीन जोन बना होता है. That zone is you will get the maximum fuel economy because I don't need power at that time and air fuel ratio is set lean at that time. And after some time, the speedometer goes up to 70. After 70, it becomes red or orange. It means here the fuel consumption will be more, because that zone is tuned with high fuel, so that you get more power, because more power is required. Wind resistance is more, road resistance is more, frictional losses are more. To overcome all these things, if you want to speed of 110, 120, 140, 150, you need more and more power, more and more fuel. It is extra rich fuel. So high power means more fuel. Higher fuel economy means when you want more fuel economy, you have to lean the mixture. Right? So this is power enrichment. Next is air fuel ratio feedback correction. Feedback correction, you might have heard about the oxygen sensor or lambda sensor. Suppose you want to maintain air fuel ratio of 14.5 at certain condition. But due to the dynamic flow rate, it is changing, varying. So I have a closed loop system. I am putting the oxygen sensor that is giving me the feedback to the ECU. No, air fuel ratio is not 14.5, it is 14.9. So reduce, make it correct. So again, it will reduce the quantity of the fuel or increase the quantity of the fuel as per the signal, and it will try to maintain in that window. That is what the air fuel ratio feedback correction. It means there is a feedback of the air fuel ratio. If it is rich, it will be made lean. If it is lean, it is made rich by the ECU. Okay. Idle stabilization correction. Okay, here I just ask you one question. Mostly you know driving. गाड़ी चलाते होंगे आप लोग, है ना? Now I am giving a condition. You start your bike or car. Start your car and stand, come outside the car. Let the car is in idling and keep that idling maybe for 5 minutes. Let it warm up. After warm up, everything is stabilized, and you put a tachometer. Tachometer means you measure the RPM of the car. It is in a, I am not changing anything. Air is same, fuel is same, quality is same, ambient temperature is also same, atmospheric pressure is also same, everything is same. So should I get the idling RPM constant or not? Constant. I should get the constant. Actually, is the RPM are constant or not? No. Why not? I'm not touching anything. Nothing is happening. मैं कह रहा हूं मैंने वार्म अप कर ली गाड़ी, आप समझ रहे हो, एवरीथिंग स्टेबलाइज. आप समझ रहे हो क्वेश्चन ये, नथिंग ऑल, इवन यू पुट ए कंट्रोल्ड कंडीशन. आपने सब कुछ कर लिया, वार्म अप करके 10 मिनट के बाद गाड़ी स्टेबलाइज हो गई. आरपीएम शुड रिमेन कांस्टेंट और नॉट? Theoretically I want, but practically it is not like that. There are maybe more, not in India, but there are many research at PhD only in idle stabilization. जैसे हम कहते हैं यार कोई बड़ा एक प्रोजेक्ट लें, idle stabilization, cyclic variations on idling. This is a very interesting area of research. First, I tell you, even after warm up the engine, suppose manufacturers say 800 RPM, idle RPM. Engine never remains at 800. It is fluctuating between 850, 840, 830, 810, 790, 750, 760. It is like that. And all cars, maybe Honda, maybe Toyota, every car. But the reason is, because when I am going for Euro 6, this is killing me. I don't want this. The first thing is, what is the reason for this? Piston movement, sir. Piston तो movement करेगा ही करेगा.
हर मतलब की जो 4 सिलेंडर इंजन है, हर सिलेंडर की उनसे होगी टॉर्क आरपीएम बदली है.
क्यों? वो आपका, मैं आपका वो केस भी न्यूट्रलाइज कर देता हूँ. That it is a single cylinder.
So there will be not 100% efficient combustion every stroke.
Nee.
In every stroke.
So ठीक है, whatever the combustion is there, I'm not changing any parameter. Suppose combustion is not 100%, it is 90%. Let it be 90%. फैन भी छोड़ दो आप, फैन चल ही नहीं रहा, निकाल दो फैन को.
जैसे इंजन का टाइम बढ़ेगा चल रहा है तो उसके कंबशन एफिशिएंसी बढ़ जाएगी, तो जो हमारे पास बाय प्रोडक्ट्स आ रहे थे
लेकिन वो तो बढ़ जाएगी तो एकदम इम्प्रूव होनी चाहिए. वो ऐसे इम्प्रूव नहीं होती ना, वो कम ज्यादा ऐसे फ्लक्चुएट करती है. यदि आपका मैं वो आर्ग्यूमेंट तब मान लूं, मैं पहले 800 थी 900 होगी 1000 होगी, कंबशन एफिशिएंसी इंप्रूव करके बढ़ गई आरपीएम, बट इट इज नॉट इंक्रीजिंग. लिसन टू मी, आई एम टॉकिंग अबाउट द फ्लक्चुएशन.
So this can depend on the density of the air.
Density of the air is not so dynamic, the temperature is changing. I am maintaining, even if you maintain the density constant, again it will vary. So this is the, I think, food I am giving you for thinking, for your brain. Just think. For this, what is the root cause of cyclic variations in idling speeds? And you can get a lot of material also. And then if you get about the spark ignition engine, then you can also go through the diesel engine also. But first go for the spark ignition engine. So idle stabilization is what I want to avoid the fluctuation. That is the calibration of that. High altitude correction. What is high altitude correction? When you are going at the hills around 15,000 feet height, 16,000, atmospheric pressure is decreased. What is the atmospheric pressure generally?
1.013 bar.
In terms of kilopascal, around 100. So, and at the hills, what is the pressure you found? Maybe 95, 96 kilopascal. So that 5 kilopascal is reduced. If that is reduced, your air density changes, and you are able to, because outside, now how the flow is taking place, outside is the pressure, engine is creating the vacuum, so that delta P will be changed. So amount of air going to the engine will be reducing. For that I have to provide a compensation, which is not possible in carburetor. If less air is coming, then I have to reduce the quantity of the fuel also. Okay. So I am naming some correction factor. Even now, 1, 2, 3, 4, 5, 6, 7, 8, 9. Around 9 correction factor is there. And calibration means you have to optimize each and every step. See, that's why I'm saying calibration is a job of 1 year. If you work 24 hours is so morning to evening. Now next is fuel cutoff. This is very interesting. I told you also. Suppose your car is going at a speed of 80 km per hour speed. Due to any reason, you are stopping car. Whenever your deacceleration mode, I want that fuel cutoff should take place. Fuel should supply cutoff, so that your pollution is low and your fuel economy is better, because I don't need power at that time. So this is what you have to tune it. But fuel cutoff to kiya aapne, but when you have to restart the fuel, that is another important point. So these are the some correction factors. So basic duration of injection plus this correction factor give you the final duration of injection. So these are the elaboration of all these warm up. ये कैसे करते हैं, temperature curve वगैरह हैं. What I have told you. Air temperature correction factor. If the temperature increases, how the correction factor is can vary. Transient, acceleration enrichment. This is what we call air fuel ratio feedback. There is a lambda sensor, or in lean mixture, the oxygen sensor output is towards 0. 0 means it may be 0.1, 0.2, 0.3 at exam. And it is maximum at rich mixture, it is 1 volt. The voltage of this lambda sensor will vary between 0.1 to 0.9 volt practically. So Accordingly, I get it and I use the correction factor depending upon the actual feedback. Idle stabilization, high altitude correction. At high altitude, atmospheric pressure, low pressure, high pressure. If the pressure is, accordingly, I can change the duration of injection. If the pressure is low, I will make the duration of injection low. Deceleration cutoff, I can cut off the fuel supply, suppose at 2000, and I can restart it, fuel cut off, and I can restart. I can make a control strategy. Okay, if the RPM are achieved around 2000, I can restart the duration. If RPM are 6000, I cut off the fuel supply. From 6000 to 5000, cut off. 5000 to 4000, cut off. 3000, cut off. 3000 to 2500, cut off. But when it reaches 2000, it can restart automatically. But when to restart, it is again a calibration. Should I restart at 2000, 2100, 1900, 1800? So that we have to check. There is one more thing to make the engine safe. We call it fly up speed. We also cut off the fuel supply to protect the engine. Suppose somebody is just accelerating and idling. So RPM can shoot up. We call it fly up speed. After that RPM, it may damage the engine. So we can limit that speed also by cutting off the fuel supply. Like in our engine, we do at 6500 or 6800. So after 6800, even if you press it, engine cannot go beyond 6800. Fuel supply will cut off. And when it is less than 6800, it will rejuvenate. Okay, can I now summarize the this enrichment? We have cranking enrichment. We have warm-up enrichment. Then we have acceleration correction factor. Then we have air temperature correction factor. Then we have engine temperature correction factor. Then we have altitude correction factor. Then we have power enrichment. Then we have fuel cutoff. Then we have idle stabilization. And then we have air fuel ratio lambda feedback correction factor. And also we have the fly up speed and fuel cutoff during deceleration. So these are around 10 parameters which you can calibrate. And the basic duration of injection, final duration of injection will be basic duration of injection multiplied by the correction factor, all these correction factors. So suppose basic duration of injection is 3 milliseconds and each is contributing 10%, 10, 10, 10, 10, 5. So it becomes 60%. So it will be 3 plus 50%, around 4.5% of that. That is the how you take the correction. Battery voltage correction factor also we have discussed. During cranking, battery voltage go down, so you have to compensate for that. So is it clear to you? Okay, can I go next?
इस एक्रोनस इंजेक्शन में आपने बोला था कि जैसे बार पिस्टन बॉटम डेड सेंटर है तो फ्यूल इंजन हमने अलग से सिस्टम लगाया है इसमें फ्यूल इंजेक्ट होगा ऐसे में वैसे तो फ्यूल इंजेक्शन होगा टॉप डेड सेंटर से बॉटम को मूव करना स्टार्ट होगा उसमें जाकर बॉटम डेड सेंटर होगा तब भी फ्यूल का इंजेक्शन होगा थोड़ा सा
नहीं, वो फर्स्ट टाइम होगा एक ही टाइम पे।
तो क्यों होगा इंजेक्शन उसके बाद में कैसे होगा?
वो आप जो स्टॉक आ रहा है उससे पहले ही कर रहे हो आप। That fuel go in the intake manifold.
मतलब जैसे फ्यूल तो एंटर करवा रहे हैं
हाँ, अब जैसे इंजन के अंदर जाएगा तो बर्निंग हो जाएगी उसकी।
एक्चुअली तो बर्निंग जब पिस्टन ऊपर जाएगा तब वो स्पार्क कभी
हाँ, तो कभी भी जाएगा। That fuel we are injecting into the intake manifold. Suppose your valves are closed. If valves are closed, the fuel will be in the intake manifold, and there it will mix with the air which is available in the air. When as soon as the valve will open, that mixture will get into the
एक्चुअली सर इंजेक्शन कौन सब कर रहे हैं उसकी स्टार्टिंग में पावर चाहिए
शिव सर हेलो
आप उसको बंद करो ना, आप क्यों ये आवाज आ रही है?
सर आई वांट टू आस्क समथिंग
उनको बोला एंड ऑफ द सेशन पे क्वेश्चन पूछेंगे।
ओके
आप भी एंड ऑफ द सेशन आप इकट्ठे कर लो, लेकिन आप ना गलत समझ रहे हैं। मैंने ये नहीं बताया पावर बढ़ाने के लिए, हमने इट विल नॉट इंक्रीज द पावर, स्टार्ट करने के लिए कर रहे हैं हम, क्योंकि तो ताकि क्विक स्टार्ट हो जाए। द फिलोसफी इज टू स्टार्ट, क्योंकि आपका पूरा साइकिल घूमेगा तब मेरा इंजेक्ट होगा, तो उससे मैं पहले ही वो कर देता हूं टू मेक इट सेफर। तो पावर, बिकॉज आई एम क्रैंकिंग एट दैट टाइम, ठीक है। नाउ वी आर कमिंग टू द इंजन सेंसर्स. Quickly, I will go through the engine sensor because I have to cover alternate fuels also. It is already 3 o'clock. So there are many engine sensors like MAP sensor. It measures the pressure in the intake manifold. Then we have the throttle position sensor. We have the temperature sensor. जितने भी मैंने correction factor की है वो सारे हम measure करते हैं. We are measuring the air temperature. We are measuring the crank position sensor. We are measuring the cam position sensor. Crank position sensor we are putting to identify the top dead center of the engine. So from here I will find out whether piston is at top dead center or it is at the bottom dead center. My all reference taken from the TDC. This is the most critical. If any sensor is not working, engine can survive, engine can work. But if this sensor is not working, crank position sensor, engine will not start. So this is the most critical, and from design point of view also, this is the most critical sensor, crank position sensor. Number of teeth, how many number of teeth should be there, how I detect the TDC, what should be the missing tooth and all that. And battery voltage also we are measuring and displaying it. So these are the in detail about the MAP sensor. What is the characteristics of this? You can find out in any books. TPS, throttle position sensor, it is a potentiometer type. As you increase, resistance will vary, accordingly voltage will vary. And the temperatures of sensors are basically simple, either your K type or at low temperature, it is a NTC type, negative temperature coefficient type. This is the temperature coolant sensor. Inlet air temperature is also on the same principle. Crank position sensor, it is a Hall effect. When some tooth is coming, it cut the pulses and it give a signal. Similarly, cam position sensor, oxygen sensor, this is basically measuring the level of the oxygen in the exhaust gases, and the principle is nest principle. It measures the concentration of the oxygen. And then oxygen sensor, and then battery voltage, we are just getting the battery voltage, we are measuring in the ECU. So we have covered air fuel ratio, mixture preparation. Now intensity of the spark, I told you in the morning, but the important thing is here I want to cover one point, that at what time we create a spark. It is very important. Generally you see, if idling, I am creating the spark at 10 degree before TDC. So as the speed increases, I have to make it advance, which is known as advanced mechanism. In mechanical system, that advanced mechanism is missing in most of the bike. They make either 10 degree or 30 degree. In between, they cannot vary. But with the electronic injection system, you can feed in the table what should be the ignition timing at 1000, 1500, 2000, 3000, 4000, 5000, and you can get the curves in the same way. Why I have to advance? Because when the engine is moving at a very high speed, time available for flame combustion is very low. So I have to advance the spark timing so that you can complete the combustion. And that we have discussed with you, that there is a ignition coil which has the primary and secondary, and that give around 30,000 volts. So with this, I think I would like to cover one complete system that I will summarize the whole engine management system. You see, this is the complete engine management system we have covered in bits and pieces. We start with the fuel system, fuel tank, fuel pump, fuel filter, then fuel pressure regulator, and the fuel is coming to the injector and going in, injecting at the intake port before the intake valve. we call it fuel delivery system. It is clear. Then air intake system. I have started from here. Air filter, we have discussed a lot. Air intake hose, coming to the throttle body, throttle position sensor, throttle valve, ISC, I have discussed in great length. Then air is controlled here and air is entering into the engine through the intake manifold. Is it clear? In this intake, we have the different sensor, air temperature sensor, throttle position sensor, ISC valve, and intake absolute pressure sensor, that is MAP sensor. Two circuit completed. Then third, come to the other sensor. You have the lambda sensor, oxygen sensor here in the exhaust. And then you have EGR. EGR is a technology which we have not covered to control the NOx emissions. So part of the exhaust gases you are recirculating. So in motorcycle engine it will not be done. It is not required, but in car engine it is required. Then you have a ECU. This is the ECU. What is the function of the ECU? All these sensor input, temperature, engine temperature, oxygen sensor, MAP sensor, throttle position sensor, all this feedback will go to the ECU. And ECU will decide when to inject, how much to inject, and it operates the injector as well as ignition system, ignition, spark timings. Correct? So based on the different inputs, it controls the injection duration, start of injection, and spark timings. With this, I want to close my engine management system. This is just sort of a introductory. Otherwise, there is a complete MS course of 2 years on only engine management system.